All right, so we've been studying factoring polynomials. Now we're going to put all those skills together. We're going to be able to use them to solve polynomials by factoring, just in the same kind of thought process we did with quadratics, but now we just have polynomials of higher degree. We're still going to give you opportunity to use those factoring skills to be able to solve and find where those polynomials are crossing that ground, crossing the x-axis, finding those zeros, we call them, or finding those x-intercepts. That's right, those are three phrases we use: solutions, x-intercepts, zeros, they all mean the same thing. So we're going to solve it today for that, maybe by factoring. So we're going to try it like we did with quadratics. We'll have everything on one side of the equal sign with 0 on the other. So I'm going to move this 18, 3x to the third, over to the left-hand side with everything else. But remember to change its sign. And as we write the terms down, I want to remember to write them in descending order. It'll always help me with the factoring process. So the first term I write down is the 3x to the fifth, moving that negative 18, or that 18 over on the side to make it negative. I do write that second, and then write plus the 15x third, leaving nothing on the other side, and that's the symbol we use for nothing. Now if I can factor things into non-factorable terms, product of non-factorable terms, then I can set all those equal to 0. Just like we did with quadratics, watch how it happens. I need to try to factor this. Common things in each. I see a 3, I see an x. So I can factor out that 3x, that common factor, out of each of these terms, leaving what I have when I do. So now I've got the term 3x times this trinomial. Again, I need to look to see if that can be factored. The coefficient here is 1, so just like a quadratic that I just looked at the video before, we can try to factor this into things that multiply to x to the fourth, things that multiply to 5 and add to negative 6 would be negative 5 and negative 1. Now I've got that factored. I look at what this is this, again, I look for patterns to try to factor. This is the difference, but not the difference of two squares, so it won't factor any more than what, it's not a pattern that I'm used to looking at. And then I look at this other term, this other quadratic, and I do indeed have a difference of two squares. So it will factor to the way we've been taught. So now I've got four things that are being multiplied. I've got 3x, I've got this term, this term, this term, all are being multiplied equal to 0. What we learned back with quadratics is if I have a number of things being multiplied and I'm told they're equal to 0, one of these things has got to be 0, or both. So what I do is use that logical thought to set each of these pieces equal to 0 and then solve those simple equations. Got x squared equals 5, so I take the square root of both sides. And remember, when I take the square root of a number, I get a positive and a negative. Solving x minus 1 equals 0. Solving x plus 1 equals 0. I get all of those solutions. How many solutions do you see? 1, 2, 3, 4, and 5 for this fifth degree polynomial. So that's how we're going to use factoring. We're going to use factoring to solve quadratics. We're going to get lots of practice on this. Hey, get stronger, get better, get beefier out on so you can't get sand kicked in your face for being a weak algebra student. We are the Ask Academy.